All right, today we are doing day 2 for section 7.5. We are going to be solving radical equations with an objective of checking for extraneous solutions. So yesterday we learned how to solve these and we practiced checking them. Today the checking part becomes more important. We're looking for extraneous roots. Our warm-ups are similar to the problems we were doing yesterday. So we'll go through these one at a time. I'll give you a moment to try them. Remember that we first need to isolate either the square root or whatever's being raised to a fractional exponent. After we get that isolated, we would raise both sides of the equation to an exponent and then keep on solving. All right, on our first warm-up, what is it that we're trying to get alone? Initially, what are we trying to get alone? X to the 1/2 power. It's got a fraction as its exponent. We're trying to get this alone. So how do we do that? Subtract the 5 on both sides. That leaves us with x to the 1/2 equals 5. Our last step really is to do what? Okay, use the reciprocal power. What's the reciprocal power of 1/2? 2 over 1, or just a 2. We have to do that on both sides of the equation. If we are taking a power and raising it to a power, what do? They cancel out. We multiply, and we get 2 over 2, which is 1. So x to the first power, or just x. And 5 squared is 25. Questions about the first warm-up? All right, on the second one, what are we trying to get alone at first? The warm-ups just say solve, so we'll just solve them. Doesn't say solve and check. On the second one, what are we trying to get alone first? The radical piece. So we're trying to get this radical part alone. In order to do that, what do we have to do? Add 2 on both sides. So we have the square root of x plus 3 equals 6. Then what? Why did we decide to square both sides? The index. Very good. If we have a square root, our index is 2. So that's the power that we use on both sides. What happens when you square a square root? Okay, those are inverse functions, so they cancel each other out. We're left with x plus 3 equals 36. Last thing. Subtract the 3, we get x equals 33. Questions about the warm-ups or what we did yesterday? Okay, we'll keep it moving then. Extraneous solutions can be introduced when you raise both sides of an equation to a power. So we have to check all possible solutions in the original equation. So yesterday our answers always worked out, so we knew we got it right. If it doesn't work out, sometimes that just means we got an extraneous solution. It seems like it should be an answer, but when we plug it back in, it doesn't really work. All right, our directions are to solve and check for extraneous solutions. So we will solve it just like we did before, and then we'll have to check it and see if it makes sense. So just like we did yesterday, what would you do to both sides first?
Add 5, subtract 5.
Subtract 5, because what are you trying to do? Good. We're trying to get the radical alone. So we are going to subtract 5 from both sides. Now, what is different about today's problem? Good. There's an x over there. So how do you think I'm going to write this? X minus 5. Just the way it looks. Okay, so that's fine. It's just a little different from yesterday. The steps are going to be the same. The way the problem works out is going to be a little different. Based on what we did yesterday, what do you think our next step should be? Square both sides, right? We're trying to undo a square root. So we square both sides. Now today, these parentheses that I'm using are going to be even more important. We are squaring both sides of the equation. We're not just squaring this 5. Does that make sense? So I would put that whole side in parentheses to square it. On the left, we're squaring a square root. What happens? Cancel out. We just have x minus 3. Okay, then on the other side, we are now squaring a binomial. So we're on the right track. That doesn't just mean that we square both of those. X minus 5 squared means we have x minus 5 times x minus 5. Right? We remember this? Anything squared is that thing multiplied by itself. So we've got the whole set of parentheses twice. Then what do we have to do? Double distribute. So we distribute the x into the back. So x times x is x squared. X times negative 5. Negative 5x. Then we double distribute the negative 5. Negative 5 times x is negative 5x. And negative 5 times negative 5 is a positive 25. Then we can combine like terms from that. Good. X squared minus 10x plus 25 is what we get there. Questions about that part? Are we all okay with squaring that binomial? All right. Now, what is our goal? We are trying to find x. If we are trying to find x and we are left with a quadratic, meaning that it's squared here, we need to get it set equal to what? 0. Somebody remembered. If you're trying to solve a quadratic, you need to get it set equal to 0 in order to solve it. So I would recommend leaving the x squared alone, leave that whole side alone, and move everything else to be with it. So if I'm trying to move this x, what do I need to do? Subtract x from both sides. And if I'm trying to move this negative 3, what should I do? Add it to both sides. If you're trying to solve a quadratic or get x alone from a quadratic equation, you need it set equal to 0. Okay? So now we've got it set equal to 0. We have x squared minus what? Minus 11x now, plus what?
28.
Good. Are we okay with those steps?
Yeah.
All right, the last thing that we have to do is solve that quadratic. There are a couple different ways we know how to do that. One of them would be the quadratic formula. The other one would be factoring. What? So Devin wants to do it by factoring, it seems. I'm going to continue it up here. So Devin, it sounds like, is coming up with those numbers that we would put if we were to factor this into two binomials. Devin, why are you saying -7 and -4? Good. If we're going to factor it into two binomials, what do we put in the front of them? X. Our variable goes in the front. And then, like Devin said, we use -7 and -4 because that would add up to -11 and multiply to +28. Are we okay with that step of factoring? It's not the only way to do this, but I think if you can factor, that's the quicker way of doing this than using the x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Right? That's our alternative at this point. We're still not done though because we still don't know what x equals. What do we do now? Very good. We have to set each factor equal to 0. All these old skills are coming back. The last step to solve this is pretty simple. What do we do? Good. So we get x equals 4 and x equals 7. Now, do we have any questions about this solving step before we do the checking step? Because I clearly need to make myself some room to check it. All right, so I'll erase this work so that we're able to check it. I will leave the original problem and my solutions so that we can see if we have any extraneous solutions here. When we go to check, we go back to the very original problem. What do we want to check first? Okay, I heard 4 first, so we'll check 4. We'll check them both. Here's our check step. So square root of 4 minus 3 plus 5. We want to know, will that come out to equal 4? So I plugged in the same x to both spots. Are we okay with that? Same x, both spots. All right, we go to check it. What is 4 minus 3? 1. What is the square root of 1? Does 1 plus 5 equal 4? What does 1 plus 5 equal?
6.
Okay, 6 does not equal 4. So that one did not work. I don't know if you want to put like a sad face by it or something. So we know that 4 is definitely going to be extraneous. Fine if you put EXT, that's fine. 4 is going to be extraneous. That doesn't mean that 7 is though. We still have to check 7 all on its own.
We just erase the 4 instead of writing.
No, I need to see that you checked them both. If the directions say to check, I need to see all your check steps. It's a good question though. Okay, so again, when you plug in x, you got to plug in the same x to both spots. So this time a 7 goes in for both of the x's. What is 7 minus 3? What is the square root of 4? What is 2 plus 5? So is that one extraneous? No, if it works, it's not extraneous. If it checks out perfectly, then it just works. It's just a solution. We got a solution and it works. That's what we wanted. That's a happy face. That's not extraneous. So I would expect that you would write both of the solutions down, but tell me that you got one that's extraneous. Does that make sense? Devin?
Are you going to ask answers?
If you have something where you've got an x on this side outside of the radical, then yes, you'll probably end up with 2.
And also,
Not always, but probably.
is one always going to be extraneous, or if they be both?
It's possible to get both of them to be. It's possible none of them will be. That's just why we check. There's no real cut and dry way of knowing this is when I'll have an extraneous, this is when I won't. These are good things to think about, though. We ready to try another one? Charles, your head moved like in a circle. Wasn't sure if it was a yes or a no. Okay, I want you to give this one a try. Refer back to number 1 if you need to. The steps are going to be similar. Okay, especially the part where you have to square a binomial and double distribute. We'll talk about it in just a minute. All right, our first goal is to get what?
5x minus 1. Or third.
Sure, we want to get the square root alone. How do we do that? Subtract 3 on both sides. The square root of 5x minus 1 equals x minus 3. Next up. Not cube both. Square both sides. Good. Square both sides. Remember to put the right side in parentheses when we square it. Okay, so when we square the square root, what happens? Okay, those go away. And what do we get on the other side?
X squared minus 3x minus 3x plus 9.
When we combine like terms, what would we have?
Wait, what do you mean by that? Oh.
So you said minus 3x minus 3x.
Oh, okay. X squared plus 9. That's what I had. I'm confused with you.
You're on the right track. If we take negative 3x and combine it with another negative 3x, what do we get?
Oh, negative 6. Oh, you get 6x, negative 6x.
Negative 6x. Okay. I agree with your first step. We just need to combine those terms. So we should have gotten x squared minus 6x plus 9. Are we all clear on that part? Okay. Then we have a quadratic. So in order to solve it, we need it to be set equal to 0. How do we make that happen? Subtract the 5x and add the 1. Are we all right with that? We need to move the 5x minus 1 over. So we do the opposite operation. What does that give us when we combine those on the other side?
X squared minus 11x plus 10.
Beautiful. Okay, this is one that we can solve by factoring. Did anyone come up with our factors? So when we put them in those parentheses, what do we write in the parentheses? Good. X minus 10 and x minus 1. Negative 10 plus negative 1 would give us the negative 11 in the middle. Negative 10 times negative 1 gives us the positive 10 on the end. Are you okay with that?
Yeah.
All right. Next up. Set them equal to 0. X minus 10 equals 0. X minus 1 equals 0. Last step for the solving. Add the 10, add the 1. X equals 10 or x equals 1. Questions about the solving process. If we didn't get there, did we see where we got stuck and how to get through it? Some people are nodding a little bit. Is anybody wanting to admit to being completely lost right now? Like you got no idea what's going on? Okay, hopefully that means nobody's completely lost right now. Are we all good if I erase this so that we can do our check? Okay. When we check it, we go back to the original problem. So we are checking to see if either of our answers or both of our answers are extraneous. Meaning it seems like it should be an answer, but it doesn't actually work out. So we have 5 times 10 minus 1, all under the radical, plus 3 equals... What should I be setting this equal to? 10. If I plugged in a 10 for the first x, I need to plug in a 10 for both x's. Under the radical, 5 times 10. 50 minus 1. Okay, I'm okay if you do both of those steps at the same time. Square root of 49. What is 7 plus 3? So is 10 extraneous? No, that one is happy. That's not extraneous. Okay, we've got to check our other solution. So this time, what are we going to plug into both of our x's? 1. Not this one. Okay, we plug in 1 to both of the x's. 5 times 1. Minus 1. The square root of 4. 2 plus 3. Is that one extraneous? Yes. That one did not work out. Sad face. So this is the one that came out to be extraneous. So we would write both of our answers, but note which one was extraneous. Okay, to get that radical alone, we start this problem by adding 3 to both sides. What will that equal on the other side? 2x plus 3. Next step. Square both sides. Don't forget your parentheses. Okay, when we square the left, what do we end up with? X plus 2. Okay, the square undoes that square root. On the right-hand side, if you need to rewrite it expanded, meaning rewrite both binomials so that you can double distribute, you can do that off to the side. When we double distribute, 2x times 2x is 4x squared. 2x times 3. Good, plus 6x. And then again, 3 times 2x is plus 6x. 3 times 3 is 9. So we can combine those x's in the middle. So we have 4x squared plus 12x plus 9. Questions so far? Okay, next we have to get it set equal to 0. To do that, what are we going to do? Well, right now they're both positive.
Subtract 2, subtract x.
Subtract 2 and subtract x. Okay. 0 equals 4x squared. What else?
11x negative minus 11.
Plus 11x plus 7. Watch your signs. Okay, this one, we are not going to be able to use the simple factoring that we were doing before. So our options would be to try to factor with bottoms up or to use the quadratic formula. Let's do a refresher of bottoms up. To do bottoms up, we start by multiplying the number in the very front to the number in the very back. What do we get? 28. We are looking for the factors of 28 that are going to add up to the number in the middle. 7 and 4. We are going to put those in parentheses kind of temporarily. Plus 7 and plus 4. But with bottoms up, we also have to remember that these are both going to be divided by what? The first number, which in this case is 4. So we have to put this over a 4 and over a 4. The last step of bottoms up is to think about if we can simplify it or if the bottom needs to go up.
Bottom needs to go up.
Okay, on the first one, this bottom needs to go up to the front. So we have 4x plus 7. And then the other one will simplify to be x plus 1. There's our bottoms up refresher. If you can remember how to do bottoms up, that'll make these a lot quicker than having to go through the quadratic formula every time.
Kind of the same thing.
Okay, it's very similar to the other type of factoring. We just have to remember the whole multiply in the beginning, divide at the end. All right. We still need to set both of these factors equal to 0. Okay, we set them both equal to 0 and we solve them both. So what do we get for x?
7 over 4.
X equals close.
Negative 7.
-7/4. And x equals -1. We'll start by checking x equals -1. Remember to plug in the same x both places. Under the radical, -1 plus 2
1.
is 1. Square root of 1
1.
is 1. All right. 1 minus 2. What's 1 minus 2? -1. And on the other side, we actually have something to calculate. 2 times -1 is -2. Is this one extraneous?
Yes.
Yes, it is. Those are not equal, sad face. So this one would be extraneous. Ajaya? Oh, good point. Why did I change that? That's going to change our whole solution, isn't it? Well, not the solution, but our whole decision there. Good call, Ajaya. That was supposed to be a 3 there. And then it does work. -2 equals -2. Now we've got a happy face. You can all thank Ajaya for that.
Thank
One person. Really?
you for that. Thank you.
Well, at least a couple people did. All right. We still have to check that fraction. We've been avoiding it long enough.
No.
Yes, it's got to happen. We have to know if it's going to be extraneous or not. You don't think it's extraneous? You think it is extraneous? Well, there's only one way to find out. We got to check it. Now, this really doesn't turn out to be so bad. If you have a calculator, especially, adding -7/4 plus 2 is not all that awful. What do we get? 1/4. 1/4 is not all that scary, especially not underneath a radical. Okay, if we take the square root of 1/4, we just have to take the square root of 1 and the square root of 4. What do we get? 1 over 2, 1/2. We can go ahead and multiply the 2 times the -7/4. -14 over 4. We can reduce that on the next step. If we take 1/2 minus 3, what do we get? Sure, if you want to write it as -2.5, that's fine. I would write it as -5/2, but personal preference, that's fine. -2.5 is the same thing. And then we need to reduce -14 over 4. -7 over 2. Is this one extraneous?
Yes.
Yes, it sure is. Those are not equal. Sad face. So this one would be the extraneous one. I think a lot of times on these, you'll get one that is, one that isn't. But you need to check both of them because you can never really be sure unless you check.
So they already did a step for us.
They did a step for us. How nice of them. What did they do?
They already added 8.
So they moved the 8 possibly. They got the radical alone for us. So we can move on and do what?
Square.
Square both sides. When we square root a radical, what happens?
It disappeared.
It magically goes away. It's not so magical. There's a reason for it, but it goes away when we square x minus 8. Can anyone tell me what we get? X squared minus 16x plus 64. If you don't have to write it out twice to get to that answer, that's fine. I don't expect to see that every time. Hopefully, you're getting used to the pattern of these. Square the first term, square for the back term, double the number at the end to get your middle. Right? -8 plus -8 is how we got that -16. Or -8 times 2. If we have a quadratic, to solve it, we need it set equal to 0. How do we make that happen? Subtract the 2x and add the 1. Okay? Now it's set equal to 0. What is on that other side?
X squared minus 18.
Minus 18x plus what?
55.
65. Now we are looking for the factors of 65 that add up to what? -18. So both of our numbers are going to be negative. So we know we're going to have x minus and x minus. 5 and 13 will do it. 5 and 13 would add up to 18. Once you have your factors, you can set each factor equal to 0 and solve. Yes, I want to see your two equations. And what are the two solutions? 5 and 13. We're getting more comfortable with the solving step. Get out another piece of paper. Okay, can we erase, well, for me, can I erase my solving step to show the checking step? Okay. We'll erase all of our solving so we can check. See if we have an extraneous solution anywhere. What do we want to plug in first? 13 equals 13 minus 8. What is 2 times 13? 26 minus 1 is 25. What is 13 minus 8? Okay, might as well do that while we're there. What is the square root of 25? Is this one extraneous? No. So this one's happy, not extraneous. Now which one do we need to check? 5. Square root of 2 times 5 minus 1 equals 5 minus 8. 2 times 5. 2 times 5 is 10. 10 minus 1 is 9. What is 5 minus 8? What is the square root of 9? 3 or? Could it be either of them? Yeah, if you take a square root, it could be plus or minus 3. So sure, I'm okay with the square root of 9 being negative 3. So is that one extraneous? No, neither of them were extraneous this time.
None of them are changed. Yeah, Lincoln used
No, just circle them. Show that you checked it. And that it all worked out okay.